Before we jump into the declaration, it is more prominent and convincing to figure out what subatomic gas pedals are. The Large Hadron Collider, LHC, operated by CERN, is a 17-mile ring of superconducting magnets. Furthermore, it is the world's most prominent and vital particle smasher. It represents the zenith of human achievement. In actuality, it is so powerful that it might replicate the exact conditions of the first second of the universe. Established in 1954, CERN is one of the world's most renowned research institutions. With 23 member states and countless scientists, it is a hub for collaboration and innovation. The LHC is CERN's primary endeavor, but it is just one piece of a vast network of accelerators and experiments. Think of it as a racetrack not for engines or people but for subatomic particles in a test of speed, energy, and the very fabric of space itself. The LHC accelerates protons to nearly the speed of light, sending them on a collision course that mimics the energy conditions of the universe just after the Big Bang. The resulting impacts create temperatures far hotter than the center of the Sun. A massive number of magnets guide the protons on their journey, while complex cooling systems keep the magnets at temperatures colder than space. The proton beams in the LHC collide at 4 locations around the accelerator ring corresponding to 4 particle detectors: Atlas, CMS, Alice, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together they act as massive cameras capturing images of these collisions. Scientists then sift through the resulting particles, searching for signs of the elusive Higgs boson, also called the God particle, and other phenomena that could provide insights into the universe's fundamental building blocks. By focusing on the microcosm, we gain knowledge about the macrocosm. Yet with every answer comes a new question, and with every discovery another challenge arises. The LHC isn't just a scientific tool, it's a testament to human curiosity and progress. It embodies our quest for understanding and our desire to grasp the fundamental forces that shape the universe. However, as we push the limits of what we know, we must also consider the deeper and existential questions that arise. What are the risks of probing the unknown? Could our pursuit of knowledge inadvertently unleash forces beyond our control? Within CERN's sacred halls, where the boundaries of human knowledge are constantly tested, a revelation has emerged that has left even seasoned scientists uneasy. Brian Cox, a former CERN scientist and a prominent voice in particle physics, recently made a statement that has both fascinated and unsettled the world. Cox's words resonate with chilling clarity. Yes, you heard that correctly, a miniature version of the very event that gave birth to our universe. The physicist further explained the implications of this goal, highlighting the LHC's extraordinary potential for groundbreaking discoveries. This includes its ability to unlock the secrets of the Higgs boson and probe dark matter, a mysterious substance that makes up a significant portion of the universe. Imagine harnessing the power of creation itself, the ability to summon the very essence of the cosmos. It is a tantalizing possibility, but one fraught with risk. The miniature Big Bang isn't just a theoretical concept, it's a very real phenomenon within the LHC. The temperatures, pressures, and raw energy involved mimic the conditions of the universe's inception. It's like standing at the dawn of history, witnessing the beginning of existence itself. In fact, something did go wrong. Back in 1978, Russian physicist Anatoli Bugorski experienced a life-changing incident while working at the U-70 synchrotron at the Institute for High Energy Physics in Protvino, Russia. A malfunction caused his head to accidentally enter the direct path of a proton beam. The beam, with unimaginable energy, passed through his skull, entering the back of his head and exiting through his nose. Bugorski described seeing a flash brighter than 1,000 suns but felt no immediate pain. The beam's path left a trail of destruction, burning tissue and bone. Despite this, he remained conscious and even walked to the medical center for treatment. The aftermath was both disturbing and surreal. The beam caused localized tissue damage, leading to hearing loss in one ear and partial facial paralysis. Remarkably, Bugorski's cognitive abilities remained intact, and he continued his scientific career. This incident serves as a reminder of the immense energy and potential dangers associated with particle accelerators. The risks of a machine like the LHC should not be underestimated. Concerns about catastrophic reactions and the alteration of life's fundamental fabric are not mere science fiction but real considerations raised by respected scientists. One of the most unsettling issues surrounding the LHC experiments is the possibility of creating a miniature black hole. Black holes are regions of spacetime where gravity is so strong that not even light can escape. They are immense vacuums, devourers of stars and enigmatic entities lurking in the shadows of our universe. The idea that the LHC could potentially create one of these phenomena, even on a small scale, is both inspiring and alarming. Could such a black hole grow uncontrollably, consuming the Earth from within? Scientists at CERN have assured the public that any black hole created would be unstable and vanish almost instantaneously. Nevertheless, the remote possibility has sparked debates, fears, and a sense of wonder about the power we wield. To understand how the LHC could create a black hole at all comes down to the fundamental mechanics of particle accelerators. When protons collide at nearly the speed of light, the energy released is immense, so immense in fact that it can mimic the energy densities present during the universe's earliest moments. This energy, concentrated into an incredibly small volume, creates conditions under which theoretical predictions suggest a microscopic black hole could form. However, such black holes, according to Hawking radiation theory, would evaporate almost instantaneously, releasing energy and particles as they disintegrate. This theoretical safety net provides reassurance to many scientists, yet it remains a topic of ongoing debate in the physics community. Despite reassurances, the mere idea of creating black holes or probing such extreme realms of physics is a double-edged sword. It speaks to humanity's insatiable curiosity and drive to understand the universe, but it also forces us to confront uncomfortable questions about the ethical implications of such experiments. If the LHC holds the potential to create phenomena capable of altering the very fabric of spacetime, what safeguards should exist to ensure our pursuit of knowledge does not exceed its boundaries? Can we accelerate particles to near light speeds and recreate the conditions of the early universe without courting unforeseen consequences? As with all progress, the pursuit of knowledge comes with risks. Despite advancements in science, the risks must be considered carefully and safety protocols must be employed. The story of the LHC is not just about the unending quest to understand our place in the universe. It is about the responsibility we carry as we push the boundaries of scientific exploration. As we attempt to unlock the mysteries of the cosmos, we must remember that great power comes with great responsibility. The consequences of these discoveries could change our understanding of everything from the smallest particles to the vast expanse of the universe itself. Scientists, including those at CERN, continue to monitor the risks associated with the LHC. Despite their diligence and the extensive safety protocols, there is still a sense of uncertainty. The Large Hadron Collider stands at the intersection of ambition and caution, exploration and humility. Every collision of particles inside its 17-mile ring is a statement that we dare to understand the origins of everything, even if the answers might shake the foundations of what we believe to be true. Yet the LHC also teaches us something more profound, that true scientific inquiry must walk hand in hand with ethical reflection. It is not enough to ask how we can probe deeper into the universe, we must also ask why and at what cost. The quest for knowledge is not a blind charge into the unknown, it is a careful negotiation between curiosity and responsibility. CERN scientists, aware of the immense power they wield, continuously refine safety protocols, conduct rigorous risk assessments, and engage in transparent dialogue with the global scientific community. They recognize that while the LHC's potential to illuminate new realms of physics is staggering, so too is the necessity of safeguarding the world from unintended harm. This vigilance does not stem from fear, but from respect for the universe's unfathomable complexity and for the delicate web of existence that we are only beginning to understand. The LHC reminds us that as we look outward, we must also look inward, at our motivations, our limitations, and our obligations to the future. In the end, the story of the Large Hadron Collider is not just one of technology discovery or danger. It is a story about humanity itself, about our insatiable need to understand where we come from, what we are made of, and what destiny lies written in the stars. As the experiments at CERN continue to unfold, they promise to open doors we cannot yet imagine. Whether they lead to answers about dark matter, reveal hidden dimensions, or revolutionize our understanding of time and space, one thing is certain: the journey of discovery will shape not only our scientific future but our philosophical and ethical one as well.